This is section 5.4, linear applications of modeling. Some things to remember we're going to need in this section: the slope formula, so that's y2 minus y1 over x2 minus x1, the domain and range, and then the slope-intercept form, which is y is equal to mx plus b. So we're going to be using our slope equation to figure out word problems. The dependent variable is going to be the y. The rate of change is going to be the m. The independent variable is going to be the x. And the starting or initial value is going to be the b. Okay. So let's read our question. A computer repair company charges a fixed amount. So fixed amount means a starting value, plus an hourly rate for a service call. A 2-hour service call is $80, and a 4-hour service call is $140. So here we're talking about dollars per hour. So the dollars are going to be y, y1, y2, and the time, the hour is going to be x, x1, x2. How much does the company charge for 8 hours of work? So first thing we need to do is we need to figure out our rate of change, which is what we're going to use our slope formula for. So y2 minus y1 over x2 minus x1. So we have 140 minus 80 over 4 minus 2, which becomes 60 over 2, which is $30 per hour. So that's our rate of change. And in our slope formula, that's going to be our m. Okay, so this was slope. Next, we need to find the b, the initial value. Okay, so we're going to pick one of our 2 points. It doesn't matter which one. I'll use the first one, which is 2 and 80. Is going to be our x and y. We have an m is 30. And we can plug those all in to find b. So we get y is equal to mx plus b. So 80 is equal to 30, and then our x is 2 plus b. 30 times 2 gives us 60 plus b. Then we need to move the 60 to the other side. So we get 20 is equal to b. So the initial value is b. That means our final formula for this equation is y is equal to 30 for the rate of change plus our initial value, which is 20. Okay, now we want to solve for, here it says 8 hours of work. So we're going to solve for 8 hours. Remember here, this was y and this was x. So it means x is hours. So we need to solve for x. Y is equal to 30 x plus 20. So 30 for our x, we're going to put in 8 plus 20. We're going to multiply 30 and 8 together. We get 240 plus 20. So y is equal to 260. So they charge 260 for 8 hours of work. All right, next question. The percent of 18 to 25-year-olds who smoke worldwide changed from 46.8% in 1987 to 37.2% in 2000. Predict the percentage of 18 to 25-year-olds that smoked in 2012. Okay, so we want to know that's not a percent. We want to know the percent per year. So that means our percents are going to be y and our years are going to be x. So our first thing, we need to figure out the slope, or otherwise called the rate of change. y2 minus y1 over x2 minus x1. So we need to label all of our information. So we have 46, 1987, 37, and 2000. So our percents are going to be our y's. So this is y1 and x1. y2 and x2. So we have 37.2 minus 46.8 over 2000 minus 1987. So we get negative 9.6 over 13. So we get negative 0.738. And that's our M. And this is percent per year. Okay, that's our slope. Second, now we need to find our B value. So we're going to take one of our 2 points, so 1987 and 46.8 as our X and Y. And we're going to use the M that we just found. Y is equal to MX plus B. So here our Y is 46.8. Our M is negative 0.738 times 1987 plus B. We're going to multiply this. We get negative 1466.4 plus B. And we're going to add that to both sides. Okay, and so we get B is equal to 1513.2. Okay, so now our third step, we have an M and a B. Our third step is we're going to predict the number of 18 to 25-year-olds that smoked in 2012. So percent smoked in 2012. 2012 is a year, so it's an X value. So we're going to write out our formula. Y is equal to M, so negative 0.738. X plus our B is 1513.2. So we're finding Y. Oops. 38 times X is, I can't write right now. 2012 plus 1513.2. So we're going to multiply this. So we get negative 1484.856. It's 1513.2. So we get 28.3%. So in 2012, 28.3% smoked. Okay, next question. Last one. A collectible baseball card, Sammy Sosa's rookie card, increases in value $50 per year. The baseball card is worth $600 now. So they're telling you that it's increasing $50 per year. So they're already giving you the rate of change. They're already giving you the M. And they said it's worth $600 now. So this is the initial value, or otherwise known as the B. So for the cost equation, you can already put the values in. So we know that our M is 50 and it's changing 600 is our initial value. So you can pop those in right away. Next, what will the value of the baseball card be in 5 years? So 5 years, we had a cost equation, or we had this equation up here of $50 per year. So that means it's dollars per year, which means this is Y and this is X. So that means this is an X value. So Y is equal to 50, then we'll put 5 in here for X value, plus 600. Y is equal to 250 plus 600. Y is equal to 850. So the value will be 850. Okay. And how many years from now will the card be worth 1750? So now this time this is going to be our Y. So we have Y is equal to 50x plus 600. So in place of our Y, we can write 1750 is equal to 50x plus 600. So we're going to subtract 600 from both sides. So we get 1150 is equal to 50x. we can divide by 50, and you get x is equal to 23. So in 23 years. Just one thing to note before you do your homework. If you have something that is just purchased or is new, it means it's 0 years old. So if they talk about a new car, or the computer was purchased in this year, or anything like that, we bought the house, that's its new cost, and it's 0 years old at that point in time. Okay, so now you're going to start on page 215, and you're going to do number 1, number 2, number 4 to 9, and number 15 to 16. And that's the end of this section.